Good morning, everyone. After the calculation of balancing storage method, that is balancing storage method, uh, through the analytical method and Muscat method, we have already chosen some value, that is 6.45 million liter per day. That is the requirement of the reservoir, requirement of the storage capacity. And next part is breakdown storage. So breakdown storage is for the emergency purpose. If there is any kind of emergency situation, such as failure of pumps, failure of electricity, or any other means, then certain percentage of water should be stored in the reservoir, so that the city might not get trouble for water supply. Okay, so that percentage is approximately 1/4 or 25% of the total storage capacity of the reservoir. Okay, this part I will show you the calculation in the later slides. Next is fire storage. Fire storage is generally taken as a conventional process. That is, if a fire break out in a moderate situation, then minimum 3 jet must be thrown to the fire from the hydrant simultaneously. 3 jet is very much important, as one stream on the burning property to extinguish the fire, and other two jets should be thrown to the adjacent property, as the adjacent property might get fired and it may propagate. So to control the propagation of the fire and extinguish the fire, 3 jets is very important. There might be requirement of another few jets, but minimum 3 jets is required. The discharge of each stream should be about 1100 liters per minute. It's a general convention. It may be changed if we use Kuchling's formula or any other kind of fire demand calculation formula, then we might get some other values, but it is a minimum value, 1100 liters per minute. I am in this problem, I am assuming this value. You people may check this value with other kind of formulas. That is their personal choices or designer choice, no issue, but they have to mention that formula before using. I am assuming that for the calculation purpose, I am assuming that a city having 2 fire breakout in a day and stands for at least 5 hours. Okay, so the total amount of water required for fire storage, number of fires into discharge into time of each fire. Okay, so number of fires we are assuming 2, and discharge is 3 jets with 1100 liters per minute into time of each fire, that is 5 into 60, that is 5 hours into 60 minutes. We are converting this into minutes, as the discharge is liters per minute. Okay, so total amount is coming 19 lakhs 80,000 liter per day, that is 1.98 mld. Okay, per day, that part is required. Okay, next, the capacity of storage, which is our main calculation, that is storage capacity required for the balancing method, that is 6.45 million liter in our case. When we have chosen that 2 lakhs population for the city and the demand is 180 liter, then it is coming through the balancing storage method that 4.45 million liter is required per day. There is a losses due to theft or wastage in some amount. Theft is mentioned as because many of the city houses are directly supplied through the local government, but a few of them may theft that kind of water. So in that purpose, there is 15% of the total consumption is assumed to be losses. In worst scenario, this percentage might be increased to 40%, up to 40%. So that is not a good distribution system, I must say, but it happens. In that case, we are calculating for the loss purpose 6.45 into 0.15, that is 15%, equals to 0.91 million liter. Okay, per day this much of amount of water must be stored regarding the losses. Breakdown storage, we have earlier assumed that 25% of the total storage capacity, that is 6.45 into 0.25. I am repeating, 6.45 into 0.25 equals to 1.61 million liter. Okay, here we have, I am clearly written from the fire storage. In earlier slide I have mentioned that 1.898 million liter that is required. The total storage will be the summation of these four categories. Okay, that is ultimately coming 11 million liter. Hence, it is recommended to design the reservoir of capacity 11 million liter as suitable numbers. Here I am mentioning about the suitable numbers, means you might not be able to design a whole tank for the capacity of the 11 million liter. In that case, you may decrease the volume or divide the volume for a single reservoir, or you may change the capacity of the reservoir, as sometimes you may be divide by 2, that is 5.5 million liter, or you may change that part in another way, that is two of them are 4 million liter and another one is 3 million liter in various point of the city. That is the choice of the designer. Okay, now that is my part. The next part will be taken by Mr. Minmay Sarkar, your beloved sir. Okay, thank you. If there is any kind of question, you do not hesitate to ask me in the group, and please mention this video with your name, and that will be show me that you have already gone through this video. Otherwise, I will not be able to understand that you have gone through this video. Okay, thank you very much.